Good morning and welcome to Race Industry Now, the weekly webinar series from EPARTRADE, presented to you by ARP, Performance Plus Global Logistics, PIC, Shopmonkey, Fifth Third Bank, Motorsports. I am Francisque Savignan, the founder and CEO of EPARTRADE, the global platform for the performance and racing industry. This is episode 342, and we're going to be talking dry sump oil pump with Peterson Fluid Systems. With me this morning are Judy King, the co-founder of EPARTRADE, and our wonderful host, Mr. Brad Gillie. Judy?
Thank you, Francisque, and thank you, everybody, for joining us today. I'm very proud to have Peterson Fluid Systems on. I've worked with them for 20 years when I was at the PRI trade show. They are a top brand and leader in oil and fuel systems. So very proud to have them. And in my book, they are committed to manufacturing here in the United States. So that's even better. Love them. So Brad?
Well, thank you, Judy, and thank you, Francisque, and great to see you both, by the way, and really appreciate it. Looking forward to this one for sure. Today's topic, dry sump oil pump cavitation, Causes and Cures by Peterson Fluid Systems. And our panelists will be joining us will be both Justin Slager and Wade Moon with Sales and Customer Service with Peterson Fluid Systems. So we look forward to getting them on. And while we do, I do want to remind you that if you have a question, you can always type it into the chat as the conversation goes on. And it's already been great to see the chat fairly active this morning. And hello to Finland, people watching from there, Las Vegas, Nevada, and everywhere else where you might be watching here today. Really looking forward to talking about a great topic and certainly educating ourselves on oil pump cavitation, the causes and cures, and what Peterson Fluid Systems can do to help you out with that. Because obviously everything we talk about here with Race Industry Now is very important and very helpful when it comes to the racing industry. And certainly today's topic, no doubt, is going to be another one of those. So Judy, Francisque, thank you so much. We'll see you guys here in just a little bit, and looking forward to a great 45 minutes to an hour here. Thank you very much.
Have fun.
Thank you, Brad. We're going to wait for Justin and Wade to join. I see their mic is on, but we need them to stop their videos. There you go. Beautiful. Thank you very much, Brad. You're in.
Awesome. Thank you, Francisque. Really appreciate it. And Justin, Wade, how y'all doing today? Welcome.
Good. How you doing?
Doing great.
Doing fantastic. Yeah, doing great. Really excited about this. Before we really get started with everything and all the questions and all of that, did you guys have a little bit of show and tell that we wanted to hit on first?
I mean, we want to share with some of the presentation we're going to be doing, but we don't really have any sales material we're going through on that.
Okay, I wasn't sure if you guys had a video that you wanted to start with or something else, but we can just. Okay, that sounds good. We'll just dive right in. Really appreciate you guys coming on today, and very much looking forward to talking about this. Give us an overview of exactly what we're going to be talking about with our topic and oil pump cavitation.
Well, cavitation is probably one of the most misunderstood things when it comes to fluid systems in general, whether that's oil, water pumps, fuel pumps, any kind of thing that involves kind of racing fluid systems, or even boat systems and stuff like that. So it can be, especially for new users of dry sumps or high performance oil systems, it can be a very daunting task, and I'm trying to understand what that is. We just kind of want to give everybody a basic understanding of what cavitation is, how it's created, how we can kind of address certain areas to fix the issues that a customer might be having.
Interesting. Well, when we talk about cavitation, and let's just start by talking about what it sounds like. What are we looking for?
Sounds like a hammering noise in the oil pump. It'll shake the pump, vibrate. It's very loud. It can be very, very loud too.
Yeah. Go ahead.
One thing you might hear a whistling, perhaps. Of exploding air bubbles. You can have that. You can actually see a pump vibrate. You can feel it when it gets hot. So you reduce the heat carrying capacity of the oil when you have cavitation. Because basically what cavitation is you have vapor bubbles that are forming on the outlet side or the pressure side of the pump that are imploding with a massive amount of force. They've been upwards of 300,000 PSI and massive temperature that will pit or corrode a piece of the pump and break it off and send it through the oil system. What we really focus on with us is we want to make sure that you're getting the proper amount of oil into the pump, so you get the proper amount of oil out of the pump, and you're not cavitating it. So when we're talking about different areas of cavitation, it's good to understand certain kind of pressure scales that you have. So the things that we're always looking at is, well, there's absolute pressure, which starts at the complete absence of anything. And then there's gauge pressure, which you're seeing in your engine on your pressure gauge, reading it in PSI. Absolute pressure is measured in inches of mercury, or PSI-A as it's designated. And then we also have to understand what the nature of air and oil is. So air naturally occurs in oil. It's something at the molecular level that will never go away. And that would be what would be considered dissolved air. And then there's also entrained air, which would be air that's added to the oil, whether that's through a leaky hose, you're sucking air out of the engine when you're scavenging, and you're not getting it out of the tank properly. It's not venting, it's not getting rid of all of that before it goes back into the pressure section. And those are kind of the way we're looking at air and how it gets into the system, and how we can mitigate those risks for the engine builder, for the racers, so they don't have engine issues down the road.
Mm-hmm. You know, it's interesting when you start talking about describing the sound and all of that, you know, and obviously we're talking today specifically about it, but if I'm hearing something, you know, it could be any number of things that I would imagine going through my mind. Do you find that people might mistake cavitation for something else? And what do we need to do to be maybe more in tune with this?
Definitely they can. Other things you can watch for is fluctuating oil pressure, oil temperatures that start getting really hot, and you can feel the vibration. I mean, you can hold your hand on the pump and actually feel the vibration, and it can get pretty severe.
As far as damaging parts and pieces, I mean, you know, obviously these things aren't made to necessarily vibrate, and especially under, you know, pressures like that you're talking about. What can it do as far as damage to your oil pump?
It can erode the surfaces on the rotor inside the body here. I don't know if you can see this inside the body, which increases the clearances, and the pump starts it's not efficient anymore. And it can actually erode it enough to where it breaks pieces off and sends it through your entire oil system.
The main damage you'll see with cavitation is going to be pitting. You'll see little just divots dug in to either the rotor or the pump body on the pressure outside is what you're mainly going to see. I mean, it can damage lines as well, but that would be more of a solid line, not a hose.
Mm-hmm. You know, it's interesting. Like, you know, on the one hand, I think, okay, if you have it, how do I stop it? That's one question. But the second question, and probably very closely related, what do I do to prevent it?
So one of the things that is a massive problem that we get questions on all the time is if line size plays a massive role in where you're going from your tank to the oil pump. And this would be, well, a tank on a dry sump, or if you're doing an external wet sump pump, you'd have the same issue where the line size, you have to have that size correctly to have it flow. We just talked to a guy not long ago. He decided that because it plumbed easier, he used a -8 line on his pressure inline, which created a massive restriction to his pump, which caused his pump to cavitate. And with what we ended up ultimately recommending to that customer was you need a -20 line to make that fit correctly and get the proper amount of oil to your pump. So line size is a huge thing. the amount of fittings in your suction line can cause a lot of issues, and the amount of bends that you have. So we always recommend you want a line that's as straight as it possibly can be with as few fittings as possible to allow that oil a straight shot into the pump.
That makes sense. There are a couple of questions from the chat that I want to touch on as we're talking about this, if you guys don't mind. This is the first part of it. I'll read it in 3. Is not any system that uses fluids to function suffer from aeration and cavitation? And then the follow-up, would it not be better to remove as many sources of air contact with the fluids as possible in any fluid handling system? And then it follows up with, aren't we talking about hydraulic inefficiency? How do you answer that?
Well, cavitation would be, yes, hydraulic inefficiency. And yeah, we do want to try and eliminate as much air as possible that we can. That's where the number of bends that you have in the system, the type of fittings that you have can play a role. Obviously, with a oil system or any hydraulic system, you don't want a hard 90-degree turn. You always want gradual bends. More tube type fittings instead of a regular just thread in. It's going to make a hard 90. Anywhere that air could accumulate and create where you're not getting a straight flow of oil or fuel or water would create areas of cavitation. Where it comes in line with the tank, it would be a properly designed baffle system that would allow the air to exit that tank in a timely manner, and it's the most efficient at getting rid of that air when it's coming out of the engine when you're creating that vacuum.
Yeah, that makes sense. That definitely makes sense when you're talking about line size and everything. And saying, hey, too small if you're not able to get enough. Is it possible to be too big as well? I mean, how do you find that right balance?
I don't think you could be too big on line size. And we usually try and direct somebody, it's better to be bigger than smaller on it. Just because it won't hurt you any. It's just more storage of oil right there. The fluid moves easier through a larger hose. So too big, I don't think will ever hurt you. Too small definitely will.
Mm-hmm. When we talk about air as well being introduced in the cavitation, what does that do as far as foaming of the oil goes?
Well, aeration is different from cavitation. Aeration is the introduction of air into the fluid. So like the pickup becomes uncovered, you got a crack or a leak in a line, something like that. That's how oil becomes aerated. Cavitation is done with the inherent air that's in the oil. That's what is being released. And oil can have up to 10% air in it.
Just normal, and that's at the molecular level.
Yeah.
Typically at sea level, it can have as much as 10%. So we obviously want to keep that air in the oil. We don't want to let it get out. So obviously, like with using water as an example, where we're at in Colorado, because the atmospheric pressure is lower, our water boils at 203 degrees as opposed to sea level is 212. Well, the same forces act on the oil. Now, oil has a much higher boiling point. Typically, you're looking at 500 plus on most oils. So we don't really have to worry too much about that unless you have an engine that's running 270, 280, like a typical dirt late model will in oil temp. You put a really small line on that supply line to the pump, then you don't have enough. You create this vacuum in there of 25 inches, and then you're pulling that oil that's already hot and it can't move through that line fast enough to feed the pump. It could lead to boiling of oil and creating that issue. So that's where the whole line size and everything, because a line will use atmospheric pressure first, a pump will when it's pulling the oil through. Once that is maxed out and there's no supply to the pump of oil, it will start drawing air out of that solution at the molecular level and get it to where it's going to cavitate. And when a pump cavitates, and what Wade was talking about earlier with the aeration and cavitation, they are different because there's two different really forms of cavitation. You have gaseous cavitation, where we're drawing air out of solution. And then we have vaporous cav. And that's where basically oil is added to the solution. And then and vaporous cav will cause a ton of damage to the pump. Gaseous cav will not. You'll hear it, you'll have fluctuations in oil pressure, but it won't actually damage anything. With vaporous cavitation, the bubble will form on the outlet side of the pump where you'll have air molecules that will bond together into a larger pocket of air, and they will explode in a microsecond when they're on the pressure side. It happens extremely fast. We actually have a kind of an image of what that looks like, and that we can kind of show you guys so you have an understanding.
That'd be great.
So the first one that comes up that we're going to have shared, so that's an aerated tank. So that would be a tank that has air added to, or maybe you have a line that's leaking and the pump is able to pull vacuum through that leak, so it's getting air into it as it's going in, and that will cause the cavitation damage on the pressure out. And then, is that showing up properly, Brad?
It is, yeah. No, and that's a great graphic too.
So as you can see, I mean, we have the entrained foamy air from the tank, and then we have kind of the bubbles that are showing there on the pressure outlet side where that oil is getting accelerated, creating pressure from the rotors, and then creates that damage. And then we have the next one, which would be a suction line restriction. So this would be too many fittings in a system, sharp bends, a kink in a line, anything like that, that would
Too small a hose.
create, because one thing that fluid systems don't like, they don't like going from a large hose or tube to a smaller one and then back to a larger one. So anything like that, we definitely want to keep out of the system. And this is kind of showing that. And it ends up having the same end result on the pressure outside, but it's caused by two separate things. One's aeration, one is bringing in air from another. You're not aerating the oil, you're adding air at a different point. And then we have what actually happens to the air bubble. So as the first picture shows, that's kind of the pressure all around the outside of it as it's coming out that pressure section. It'll start imploding in one small area of that bubble, slowly growing until what a lot of people consider they call it a vapor jet. And that air is moving extremely fast under extremely high pressure. And that's what actually causes the damage to your rotors or your pump housing and causes the pitting to happen.
That's interesting. Especially seeing that graphic in the way that you're showing it and why the pitting happens and all of that. A couple of questions, if you don't mind entertaining from the chat, unless you had something else to show first. Okay. Means. All right. Let's see. I think you sort of touched on this a little bit, but let's talk about it again. Does oil supply line length also play a role in cavitation if you just simply have too long of a line?
Yeah, it does. The longer it keeps getting, the bigger diameter you got to make it. Like Justin said earlier, we had a customer that it fit better putting a -8 hose on, but he lost a motor over the deal. And when we got all down to all the specifics on it, we recommended that he had a -20 hose coming from where the tank was because it was so far away. His suction line was like 12 feet long.
Wow. When you're looking at something that long too, does that, I can't imagine that wouldn't change maybe the amount of oil that you'd want to be putting in your tank as well?
Sometimes a larger tank would be better.
The main thing with that's not always going to affect tank size.
Okay.
The main thing we're looking at with the tank is, does it fit the style of racing? Does the oil spend enough time in the tank to properly deaerate? So like with a drag car that runs for 8 seconds, we can use a much smaller tank because we don't have to worry about the buildup of air that we would in an endurance car or a dirt late model or anything circle track, or a road race car that goes for 2 hours or an hour at a time when they're running. So the main thing with tank size selection is we really look at what form of racing are you doing, how long are your events, and we'll size a tank that way. And as long as we're keeping that oil in the tank long enough to get all the air out, that's what we're concerned with. And having more oil in a system for a road race car or anything like that, obviously we can help control heat a little bit better with the more oil we have, where we're not really concerned with drag car being in that same area. So there's a number of factors that do go into tank selection, but generally the biggest thing we're worried about is style and how long that engine runs for.
Yeah. Another question, oil pump speed, RPM, what effect does that have, especially if we're talking about different styles of racing and the way, the engines may turn?
Most of the pumps, we don't want to turn ours over like 5,000 RPM. It's rated, the parts in it are rated for higher than that, but it can't completely fill the pockets with oil. And that can contribute to cavitation then too, because the pressure drops and releases the air. So you can spin a pump too fast and definitely cause cavitation.
Okay. A couple more questions. Again, this is great. These are wonderful details too. What if there were fluids available that could be added to the system that improves the air release properties of the fluid? Is that something that's viable?
I don't know of any.
I don't know of any that would do that. I mean, there could be something out there that I definitely don't know about on that. I don't really know of anything that keeps air in solution at the molecular level better. Because every fluid has a vapor pressure. And vapor pressure is how easy it is for that air that's at the molecular level to come out. So it's always trying to find equilibrium with the surrounding air. If you think of like a soda, right? And you open that soda up, it's really fizzy right away. You get that nice taste in your mouth, fizzy, bubbly, it's great, right? Well, if you let that soda sit out for 3 hours, the solution didn't really change. The air left and found equilibrium with the surrounding air that it's with. So it found balance, and every fluid tries to find that. It's always going through it. It's kind of, to get a little really scientific, at Henry's law, which is a pressure at a liquid and the surrounding air pressure around it will always find balance. So if you increase the air pressure on a liquid, the air pressure in the fluid will actually increase as well.
Okay. And when we're talking about this, let's just say I'm a racer, I'm running into this problem. What solutions does Peterson Fluid Systems have? What conversations do we need to have? What would I need to know before I contact you?
We'd want to know the type of racing you're doing. That will determine if you got the proper size tank. If you're doing some sort of endurance racing with a 1.5 gallon tank, your problem could be coming from that because the oil's not staying in the tank long enough for it to deaerate. So you're actually getting that foam in the oil to the inlet side. We're also going to ask how fast you're turning the pump. And if you have a gallon per minute usage through the engine, that's helpful too. That's something that doesn't happen very often, but, and then we'll discuss line size, the number of bends. The most common thing we see is too small a line.
One of the things we do from a manufacturing standpoint is the way our inlet ports are designed on our pumps. They're sized a certain way, they're shaped a certain way to allow free flow of oil into that system. Our inlet size on our pumps use an 1.125" 18 thread. So it's huge. It can accommodate a -20 line, but we use that on a -12 or a -16. We want the pump inlet to be bigger than it needs to be. So from a manufacturing standpoint on that, that's how we're kind of allowing a multitude of things for the engine builder and everything. And we can ensure that enough oil, the pump will always allow as much flow as possible. One of the other things we have, and I actually have a cutaway of our dirt late model tank, would be with baffle design. So the oil initially comes in through these two fittings up here. We actually run it through a scavenge filter, which actually separates the air from the oil when it starts going in. You'll start seeing two different layers. And then it'll come into our spiral baffle up. And so we have a baffle plate here. We have these tubes that are running this way. And the air and oil are traveling down those, kind of like a centrifuge would be. And it starts spinning around the tank. And then it drops onto our lower baffle plate. So, and then we have our vent line, which vents out here, but actually goes above the level of the tank. This is where that hose runs to. So we keep this, the air is able to always rise to the top. We spin that oil around the tank, allow it to get rid of that air that's in there, and then find its way out the top. And we have great success with our baffle systems and how we design them, whether it be for drag racing, dirt late model racing, endurance racing,
off-road,
going on a hypercar or anything like that, which we've done custom tanks for in the past. So we get a lot of different areas where we can assist. The baffle design isn't just, oh, just throw a piece of metal on there that's going to slow the oil flow. There's a lot of design engineering and work that goes into what the height is, what the ultimate design is.
Yeah, that's really neat. Actually, that's pretty cool to show. You know, you guys were talking about oil lines and maybe sucking air into fittings, and you know, in my brain, I start thinking about fittings and oil lines and making sure things don't go out, making sure something's not leaking, not necessarily always thinking about things leaking the other way, being sucked in. What do you recommend? You know, and what do I need to do to maybe check that to make sure that I'm not having an issue?
Pressure testing your hoses before you install them to make sure they're, because that'll show a leak no matter which way it would be coming from. And use good quality hose with a high vacuum rating on all of the suction hoses. We see that happen a lot anymore, where they're using cloth braided hose, but the vacuum rating on some of it is very low. And especially on scavenge lines, it'll actually, because they pump air and oil, when they get a big slug of oil, it'll actually suck the line down shut. And then it won't pump nothing through it. So you have to have a high quality, high vacuum rated hose.
Yeah, that makes sense.
Anything that's on the suction, anything on the suction side of a pump should be rated for 28 inches of vacuum.
Okay.
What we recommend.
No, that's good info. Another question from the chat. Isn't sonoluminescence caused by cavitation? If this is true, this increases the heat in the fluid a ton. I guess maybe more of a statement, well, question and a statement there.
It does increase the temperature of the oil. quite a bit.
Yeah, when a vapor jet is formed, it creates a massive amount of heat. Because obviously air heats up much faster than an oil would. So when you're having that happen at the rate it does when a pump is cavitating, as often as it happens, you can definitely increase heat dramatically.
Mm-hmm. This is all just fascinating. Everything that we're talking about here, and especially with cavitation. You showed us the tank and all of that. When it comes to pump design, different things like that, are there things that can help minimize that, or are there things that I need to know, again, maybe more specifically to what I'm doing, and even how fast things are moving or how much fluid I'm moving?
The sizing of the pressure section, if you've got too small a section, and the oil flow through the engine is more than what the pump and the line size can do, that can create the problem. We got a whole list of questions we ask people on their engines to determine how we size the pressure section on a pump, because there's a lot of things that change the amount of oil that flows through the engine. Aluminum blocks and rods expand greatly when they get hot. And we've had two customers that actually put main bearings in a block, torqued everything down, measured it, heated it up to 200 and 250 degrees, and the clearance changed by as much as 5-6 thousandths. So, which it dramatically increases the flow rate through the engine. So you might have an engine that you used all the same stuff on that had a -12 suction line, and then you switch to this new engine that's all aluminum, and you start having a problem. It could all be due to you need a bigger suction line because your flow rate went up so much.
That's interesting. What about, just in the way that I'm doing my oiling system, and forgive my ignorance on some of this, but is there a difference in how this might be impacted, wet sump versus dry sump, if I'm, using oil coolers and different things like that? Are there more specific things I need to know based on my system in that regard?
I mean, generally the cooler the oil is, the better it's going to perform. So having coolers, all of that, I mean, that's always beneficial. Sometimes with the style of racing you're doing, it might not matter. The drag racers never generally get enough heat that we have to worry about it. Obviously, with cars that run for a longer time, whether that's a marine application in a boat, a circle track racer, a street car, obviously we want to take that into account. We want to try and help them keep their oil temp where they want it and where that engine is going to perform the best. And that really comes down to a lot of the discussions we have with engine builders and what they're looking for, or the racer, of what's your goal, so we can kind of direct what we're going to size to fit that and how we're going to design the system.
Mm-hmm. Interesting. One thing I love about a lot of the people that we have here at Race Industry Now, and a lot of the suppliers such as yourself, is that it always seems like there's a great customer service base of racers talking to racers. And, whether it's phone conversations, trading emails back and forth of, hey, this is what I'm doing, what do you recommend, and all of that. How does it work over at Peterson Fluid Systems?
Oh, we got a lot of people that race, for sure. I mean, I've done road course racing for several years, more of an amateur level. Our main tank fabricator and guy who manages our pump room, he races sprint cars. We have drag racers that are building our pumps. So racing is ingrained into what we do. Wade built race cars for over 30 years. So when you're calling us, we don't just know about the oiling systems, we also know about racing in general, which can definitely be helpful. We understand what you're talking about when you have the problems that you're calling in with.
Yeah, and that's one of the wonderful things, and especially with your background and all of that. What are some of the common issues? I know you talked about line size and all of that, but sometimes someone has an idea of, hey, this is the way I want to build it. Sometimes the idea of the way they want to build something is also, let's be honest, for something to look really cool, but it might not be the most efficient thing. What are some of the common, I want to say errors, but maybe that's the best word to use here, that people might be doing with their oiling systems that you guys hear often?
First is always line size.
Yeah.
They don't understand that. The other is tank size. We see this more with cars that run for extended periods of time. They might see a tank on a drag car and think that, okay, that's going to work great for me. It's the dry sump tank, when that tank isn't necessarily the best choice for them. People buying used pumps on the market because it worked on this engine, so it's going to work on mine. Well, those engines are built completely different. The only thing they really have in common is, yep, it's got a crank and rods. And after that, they're vastly different, because a dirt late model engine as opposed to a drag race engine, yep, they're both engines, and that's where the similarities end. Because like a dirt late model engine will take 16 gallons a minute of oil, where on an all aluminum and an all aluminum drag race engine might require 10. So the pump size, they think, oh, I need a high volume pump because I make this much horsepower on my engine. Well, it's not always the case. When we're looking at bearing clearances and oil usage rate and what your goals for the system are, and oil viscosity that you're using, all of that plays a role in how we're sizing a pump for the customer. And that, it can be daunting, especially for first timers, or even for people who understand it, fully understand, because we can pump 31 gallons a minute with one of our high volume pumps, which isn't always the best choice for an engine, because you can drown an engine in oil, which isn't going to help you at all. And then, or supply too little. So pressure size, section fitment is really good. It's really important to the overall design of the system. And it's where we basically start from, and then work our way to build the other products.
Is it ever a solution if someone says, well, I've got a pump that flows maybe more than I need, but I'll just help it by using a smaller line and restrict it on the outside?
There has people in the past have thought that, yes. It's not the proper way to do it by any means. Plus, if you got too big a pressure section, you have a hard time getting rid of the pressure that it creates, because it can't bypass that much. And so to turn a pump at 100 psi when you only need 60 or 70, it creates a lot more horsepower, or it needs a lot more horsepower used up. So, racers will spend thousands of dollars to find 10 horsepower and then run their oil pressure way too high and lose it all. Lose everything they spent to gain, they lose it on the other side, just because they can't get rid of the oil pressure.
And if you're trying to get rid of pressure by going to a smaller line, you're not. You're actually going to increase the pressure, because the volume's going to try and stay the same. Where volume and pressure are separate, but yet they work in tandem together. The more volume we put in something, the more pressure it's going to create. So if we're trying to shove the same amount of oil through a smaller line, we're only going to increase the pressure.
Yeah. See, this is where your expertise helps a guy like me who's really good about thinking of the wrong way to do something, for sure. A question said, do you ever see rubber hose collapse? And I'll even follow that up with, well, how do you feel about rubber hose?
If it's a real high quality braided with an inner rubber liner and it's got a high vacuum rating, it's fine. If it doesn't have a high vacuum rating, it doesn't matter what kind of hose it is, you're going to have problems.
Yeah, just because it fits doesn't mean it's right.
Years ago, I sold a system, two systems, to a dirt late model customer and went to Speed Weeks and went by his trailer, and he was mad as could be at me because he was having all kinds of oiling problems. And I tried to help him and stuff, and we couldn't get it. And so over the next week when we got back, he called and asked if he could return the stuff. And I told him, yeah, I don't want, you're not happy and I want you to be happy. I don't know what's going on. So he put his old stuff back on, his old pump and everything. The pump worked just fine. He had the exact same problem. The only thing he had done is he had bought brand new hose and made up new hose. And his scavenge lines was not rated at high enough vacuum, and it was sucking shut. So it would run the tank dry and leave all the oil in the motor. And it didn't matter whose pump was on it, did the same thing. So you want to have a high vacuum rating, because he tried racing for a full week and never could finish a race. And, so the hose cost him quite a bit, having the wrong hose on.
Wow. You'd mentioned viscosity earlier, and getting back to the original topic of cavitation, how much of an influence or an impact does that have?
It can definitely have some. I mean, it's not a leading cause of it. But if we're talking like a 0 or a 10 weight using a pro stock engine or something like naturally aspirated, high RPM running engine, as opposed to a high boost application where they're running a 2050 or a straight 50, or in some of the diesel pulling world where they were around 70 weight, then line size can play a role in the viscosity of oil you're running. A much thinner oil we can use a smaller line on than, say, a straight 50 weight. We may recommend, hey, typically we'd say a 16 on this, but you're running straight 50s, I'd probably do a 20, right? And where a 0 or 10 weight, we won't have to worry about that because it flows like water no matter what. So there can be a slight issue with it, but it's usually nothing that we're super concerned with, but it can have a slight effect.
Mm-hmm. It's interesting, and just in talking, the one thing I keep formulating into my mind is just simply balance, and not saying, hey, I need this pump, or hey, I need this tank, or here's what I'm going to do with my lines and or my fittings and all of that, but really how the whole works in one, and maybe thinking in that way, especially if you're doing a new build or some type of race car, thinking about the whole of the system and what you guys have to offer.
Definitely. It's every system is custom. You can tailor it to every type of engine, every type of racing. They all look the same on the outside, but you've made a lot of changes on how it's put together.
Mm-hmm. Does do different things, like all of a sudden I have this naturally aspirated motor, and now I want to change it and do some sort of forced induction, and everything else is going to change. What kind of an impact does that have on the oiling system, from the pump, the lines, the tank, and all of that?
First thing that happens is most of the time in a boosted application, the bearing clearances get larger, which increase the flow of oil through the engine, where all of a sudden your pressure section may not be large enough. So that can be, that can greatly affect it. The tank, you might want to have a larger tank, just because there is a tremendous amount of air getting into the tank on a boosted application versus a naturally aspirated.
Can I plan for that? If I'm doing one thing and think that, hey, maybe on down the line I want to add this to it, could I get something now that would be okay, but that would ultimately help me for my end goal, or is that just completely a wrong way of thinking?
It's possible. Yeah. I mean, if you talking to us and you're like, oh, I'm naturally aspirated now, but I'm planning on boosting in the future, and I'm keeping my same rod and main bearing clearances, I'm doing this, I mean, another thing to add with boosted applications as opposed to naturally aspirated, your cylinder head pressure goes up, or your cylinder pressure goes up, which creates more force going down onto the rod main bearings. So generally we want a higher pressure into those as well to protect those bearing surfaces so the oil doesn't collapse. That oil wedge that you get in those, it doesn't collapse as easily. But so if you say you want to do a naturally aspirated, you plan on boosting in the future, you don't want to buy 2 separate pumps. We can oversize the pump. At the time, it's not always the best solution and not the best way of going about it. And then we also make a remote pressure relief, which will allow us to dump the unused oil back into the tank or into an oil pan if it's a wet sump. And it will keep the volume that you need for perhaps later additions to the engine. It's going to take more horsepower to turn the pump. You're going to generate more than what you need pressure-wise, but we could build a system where we get rid of that extra oil pressure.
Okay. Getting back to, again, the cavitation, say I'm experiencing this. Fair to say the first thing I need to look at is line size. And then beyond that, if that doesn't necessarily solve my problem, where do I need to go?
Pump speed and tank size for the application that you're using it on. If you're endurance racing with a really small tank, you're probably going to have a hard time getting the air out of it. So now you're feeding the pressure section of the pump with aerated oil. It's foamy because it didn't stay in the tank long enough to let all the air percolate out after it ran over the baffle system.
Okay. This is great. I'm really enjoying the chat, by the way. A lot of compliments to both of you. In fact, the last one, Bob May, fantastic presentation. Oil control is the heart of an engine. Peterson has been a leader in this area for years. Thank you for the information. And I'll echo that. Again, we always learn something on these Race Industry Now webinars, and something that's going to benefit racers, and what you guys have taught us today and also have to offer for racers is just wonderful. Thank you so much.
Thank you.
Appreciate that.
Thank you.
Well, thank you. Brilliant presentation. And you're right, Brad. We learned so much. I mean, there's so much expertise with those two guys right there, you know.
And I have never seen so many nice comments. So Wade, Justin, good job.
Yeah, that's true. Out of 342 episodes, that's probably, good job, guys. So this webinar has been recorded. It will be posted later on the EPARTRADE platform. It will be distributed through our newsletter, our social media channels, and all our channels. We pushed Peterson Fluid System back on the homepage of EPARTRADE. So please take advantage of the EPARTRADE platform. It's open 24/7, 365, and accessible from anywhere you are, from anywhere in the world. So thank you very much for being with us today. We will be back live next Wednesday, again with our wonderful host, Brad Gillie, and we're going to be talking power distribution module and intelligent power distribution with Raw Electronics. Thank you very much. We'll see you guys live next week. Bye-bye.
Thank you.
EPARTRADE is a digital platform that we've created basically to make life easier in the business community of auto racing.
EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
I'm Michael Cruz, owner and operator of Got Mechanic LLC. Whether we're out in the field or whether we're in the bay, me and my guys are able to actually go into parts procurement and be able to pull up these prices for our parts and use the parts matrix to actually get a profit off of these parts on the fly. Parts procurement makes it even better just with being able to get in contact with my local retailers.